So now that we've talked a bit about the Executor framework at a high level, let's give an equally relatively high level overview of what a thread pool is, because that's crucial to understanding the benefits that are provided by the Executor framework. We'll also give a human known use of thread pools. As you'll see as we go through all the various threading mechanisms and synchronizers that are part of Java, I try my best as much as possible to give human known uses. And that's because I think a lot of times people get lost in all the nomenclature and the concepts and the mechanisms of concurrency and synchronization and miss out on the fact that we're actually quite familiar with these things from day-to-day lives. A lot of stuff that we do in the real world ends up with multiple concurrent actors, namely people, coordinating their actions through various means, like passing messages back and forth or other things that they can use in order to ensure that they work together in a cooperative way and don't stomp on each other. So let's first talk about what a thread pool is. One of the reasons for using concurrency, especially in multi-core environments and large cluster environments, is to be able to handle a larger number of clients. And we'll use a simple example here. Let's imagine we're going to build a website for something that needs to handle a large amount of load, like, say, the Olympic website, if we ever have an Olympics again in person. And in that case, you might have a web server or web servers that have to handle thousands or tens of thousands or hundred thousands of client requests simultaneously, because everybody wants to come and see what the latest values are. Other things that would be examples of this, of course, would be stuff like the YouTube server or cloud servers that are used for popular events and so on. Well, one way to do this, one way to implement such a web server would be to spawn a separate client thread for each request. But that approach, while very simple, as we'll see, just doesn't scale because you end up with as many threads as there are clients, and that can quickly overwhelm the resources on the computers that you're running on. So here's just a simple way you could do this if you were so inclined. Let's say that there's a method in your server called handle client request, and it takes a new request. And what we do here is we say new thread. We make a runnable that will provide processing for that request. We have some factory method called make request runnable that associates some computation, some task with that request. And then we start that thread. So for each client, there'll be a thread. Well, this, of course, is going to have several problems. Number one, threads don't come for free. So as you probably remember when we talked about threading before, there's resources that are allocated, there's runtime stacks, there's various thread-specific storage resources, there's registers, there's all kinds of things, virtual memory and so on, that are created when a thread is started. And that will eventually overwhelm the resources on your computer. Even if you have a lot of memory, you'll end up chewing it all up with all these different threads. And that's not necessarily a good thing. Even if you are on a system that has lots of memory, such that you can spawn lots of threads, it probably means you've got trouble, because with lots of threads comes a lot of overhead by the operating system to keep track of all those threads and maintain them and switch between them and so on. And so the internal data structures will get big and slow, and the whole thing will just sort of clog up. Moreover, and probably the most obvious thing, you probably don't have anywhere near the number of cores that you have the number of threads or the number of client requests. And that's ultimately the limiting factor in these systems, is how many things can you really do simultaneously or physically simultaneously, because you're ultimately limited by hardware. So what's a better approach? Well, oftentimes, and in fact, almost often, a better way to do things is to use some kind of a thread pool. So rather than allocating a thread per client request, we're going to allocate a smaller number of threads, typically something that's tuned to the number of cores one way or another. And then we're going to let those threads run on those cores, and then we're going to multiplex the client requests atop them. Why is this a win? Well, it's a win because you can amortize thread memory, you can amortize processing overhead by basically pre-allocating a number of resources, maybe a fixed number of resources, maybe a slowly growing number of resources and so on. But the point is that you're not going to be allocating as many resources as there are client requests to do the concurrent computation. You'll instead tune it closer to the number of cores that actually can run in parallel. So here's here's a way you might do this. This is just a little pseudocode to kind of start orienting your thinking about this. We'll look at more details shortly. So in this particular example, something that allocates a new thread for every request could be replaced with something that makes an executor, when we're going to talk about the different kinds of thread pools you can have with executors in a minute. And then when a request comes in, you say, make request runnable, make yourself a runnable, and then you call the execute method on the executor. And as we'll see, that does some clever things behind the scenes. A couple things to think about. How big should the thread pool be? That's an obvious question, right? If we're not going to have a thread per request, what should our thread pool look like? Our thread pool size look like? And the answer here is it really depends on a couple of factors. It depends on the number of cores on your CPU. It depends on whether your tasks are compute bound, or are they IO bound, or are they synchronization bound? There's different things they might be bound by. And so based on the answers to those questions, we'll talk later about ways to optimize the size of the pool. The thread pools that are created, in Java at least, are bound to a work queue of tasks, or work queues of tasks, that will wait for work to show up, and then they will process that work. So there's typically one or more queues that then feed the pool of threads, and they coordinate and interact using synchronizers, of course, or message passing. There's a couple different ways to do it. And the worker threads behave like so-called hungry puppies. If you've ever had hungry puppies, you know that when you put the food bowl down, they all come over and kind of put their cute little snouts into the food and chomp away, waiting for the food to show up and eat the food. So the worker threads basically wait on the queue or queues for work to do. And when work comes in, they will consume it, just like the hungry puppies eat the puppy food. So let's briefly talk about some human known uses of thread pools, now that I've given you just an overview of the mechanisms and some of the features that you would expect to find with thread pools. So the classic example of a thread pool is a call center, where you have a bunch of operators, humans, standing by waiting to take calls. And of course, things have progressed quite a bit since the old days of call centers and switching centers, where everything was done very manually. Nowadays, you would typically have a group of people. They used to sit in a room. Now they probably are distributed across the world because people don't like to sit in rooms together at the moment for obvious reasons. And there's some kind of call center manager that will queue up the incoming calls and then distribute them in some order, typically a round robin like fashion, to the next available operator. And I'm sure you've called up a call center before if you want to make a flight reservation, or you want to talk to someone about your credit card, or you want to get some help from Verizon or AT&T when the service goes down, or whatever. Undoubtedly, you've called some call center before, and it usually says something like, your call is important to us. All the operators are busy. Calls will be answered in the order received, so please don't hang up and call back. And so basically what that's saying is we're going to queue you in a queue, and then when someone's available, we'll switch over automatically to the next person to take the call. So that's a good example of a thread pool, because obviously you don't have a new operator for every caller, but instead you have a fixed number of people, and you have a way to queue up requests to deliver that request to the fixed number, or maybe a variable number of people in the caller pool. Okay, so that's a quick overview of thread pools. Of course, we will go into a lot more detail shortly and discuss how you program these things and what Java supports, but I just want you to have a good sort of gestalt conceptual understanding of how all the pieces fit together before we dive into the technical details.